Good evening, good afternoon, everyone. Good afternoon, everyone. Good afternoon, everyone. Please, if you're active, indicate that you're active. We are starting right away. If you're active, please just indicate that you're active, okay? If you're active, indicate that you're active. If you're active, please indicate that you're active. If you're active, please indicate that you're active. Just sign in your presence that you're active so we can start. If you're active, just indicate that you're active. Okay, Tutor is active. Who else is active? Who else is active? Just indicate that you're active. Indicate that you're active. Please do me a favor. Ensure you share this link to other students. Ensure you share this link to other students. Ensure you share this link to other students. Please ensure you share the link to other students. Ensure you share. Ensure, please indicate that you're active. If you're active, please indicate that you're active. If I'm looking at this one, diverse questions that should be expected in your exam. Diverse. We have been having this online class for a while now, and we have learned so many things. We have learned some topics in physics. We have learned dimensional analysis. We have learned vectors. We have learned work energy and power. We have learned rotational dynamics and so on and so forth. Even down to oscillation. We also saw how to find the period of a conical pendulum. All right. So this class will just be a more of 2 hours to 3 hours class. 2 hours class if our battery can sustain it, but I will try to be direct and precise. All right. Now, the first chapter of your textbook talks about measurements. Is that clear? And I want you guys to put it down. Put it down. The first question, I'll be direct. Like I told you, I said, it's just an exam preparation class. Define the following terms. Define the following terms in physics. Number one, physical quantity. Physical quantities. Number two, vectors and scalar. Number three, fundamental and derived quantity. Fundamental and derived. Quantity. Number four, dimensional analysis. Dimensional analysis. Number five, tolerance level of measuring instrument. Tolerance level of measuring instrument. Measuring instruments. I will define them. These are terms that you should know by now. When you hear the word physical quantities, if you have to define in the exam, these are quantities that defines nature. These are quantities that defines nature. These are quantities that defines what? Nature. That defines nature. Example of this quantity, if you're asked to define and give at least 2 examples. Examples of this, we have mass, we have displacement, we have acceleration, we have force, we have momentum. Any physical quantities you can lay or you can remember, they're falling under what? Physical quantities. They can either be vectors or scalar, fundamental or derived quantities. So all quantities you can remember that defines nature. You can give them as an example, right? Okay. Number 2 is vectors and scalar. We know vectors are those physical quantities that have magnitude, and what? and direction. They have magnitude and what? And direction. Example of vectors, e.g. Example of vectors, we have acceleration, we have displacement, we have force, all right, we have force, we have momentum or moment, we have weight, etc. All of these are called vector what? Quantities. These are quantities that have magnitude and direction, all right. Then we have scalar quantities. These are quantities that have only magnitude but no direction. A good example is a metric system. We have the mass, scalar quantity. Under scalar, we have our mass, we have our length, we have our time, we have our temperature, we have amount of substance, in mole, amount of substance. These are examples of scalar quantities. Please here indicate your presence that you are alive. If you're active, please indicate that you're active. If you're active, please indicate that you're active. Please indicate that you're active. Indicate that you're active. Okay, so this is one of the difference between vectors and scalar. Vectors have magnitude and what? Direction. Example, we have seen examples. Then scalar only have what? Magnitude but no direction. Another example of vector, you might be asked to differentiate between vectors and what? Scalar. Now, the first difference should be that vectors, this is the first difference between vectors and what? Scalar. Number two difference should be that vectors are added, okay, by vectors law. They are added by what? Vectors law. Where the vectors law we know there's a law called the parallelogram law of vectors, right? Where the triangle law of what? Vectors. A difference between vectors and scalar. After defining to differentiate them, the next one should be that vectors are added by vectors law, e.g. parallelogram law of vectors, triangle laws of what? Vectors. Why scalars are added by simple algebra? That scalars are added by what? Simple algebra. Okay, so please have to differentiate between vectors and what? And scalar. After differentiating the fact that they have, number one, they have magnitude and what? And direction. Yeah, they have only what? Magnitude, right? Okay, number two is that vectors are added using vectors law. Using what? Vectors law of addition. Vectors law of addition. E.g., we have parallelogram law of vectors. Then under scalar, they are added by normal algebra, by simple algebra, simple algebra. Algebra. Examples of vectors, we have what we call, you know them already, acceleration, displacement. This can also form a difference as a third difference between vectors and scalar. Now, fundamental quantities and derived quantities. Fundamental simply means they are the basic quantities. They are the basic quantities in physics. Fundamental are the basic quantities. Fundamental, they are called what? Basic what? Quantities in physics. Number two is that fundamental quantities are self-defined. They are self-defined. Number three is that apart from being self-defined, they do not depend on other quantities to define them. They don't depend on other words, quantities to define them. The major definition is that these are basic quantities in physics that are self-defined, meaning that the fundamental examples of fundamental quantities, we have the mass, the length, we have the time, okay, we have our temperature, all right, okay, temperature, we have amount of substance, amount of what? Substance, amount of substance in mole and order. They are the fundamental, meaning they are self-defined, they stand on their own, all right, okay, mass, length, and time. The metric systems of measurements, mass is measured in kilogram, length is measured in meter, time is measured in what? In second. These are the fundamental quantities, right? Then the derived quantities, these are quantities that depends on the fundamental quantities to define them. That depends on the fundamentals. That means they are gotten either through addition or through, they are gotten either through multiplication rather, or through division of two or more fundamental quantities. All right, these are called the derived what? Quantities. A good example of derived, we know acceleration. Okay, acceleration is derived. Number two, we have force. Number three, we have moment. Number four, we have velocity. Number five, we have density. Number six, we have work. Number seven, we have power, etc. Force is mass times acceleration. Moment, okay, momentum is mass times velocity. Okay, velocity is what? Displacement over what? Time. Density is mass over volume. Work is force times distance. Power is work done over time, etc. Okay, so these are derived quantities. Now the next question says, what is dimensional what? Analysis. What is dimensional analysis? I hope you are taking note of this. Okay, you should have something like this nature in your exam. I will look at them. I will just run through. Then we'll look at the first chapter, second chapter, third chapter, the fourth, fifth, and sixth. Like I said, more precise and direct. All right. So after this class, our next class will be by 8 p.m. For those that will be coming for physical class at the center, then I will summarize everything, and I will also add more revelation questions and all that. Yesterday we meet yesterday from 8 p.m. to 4 a.m. Majority came, the card was massive, people came and all that, and a lot of things we have discussed. So today by the same time, 8 p.m., we continue again in the same journey. So please ensure that you join us by 8 p.m. tonight. So I'm already announcing my class for those of you that are based in Imo State University. So please make sure you attend the night of revelation. It has never failed us. So everything we shall be discussing, we shall be seeing them live and direct. Okay, like I told them, I said about 80% of what I will discuss tonight will appear in the exam. But I will try my best, and let's see how far we can achieve little. How far we can achieve, rather, not little. Okay, so if you are active, please indicate you are active. Now, what is dimensional analysis? What is dimensional analysis? What is dimensional analysis? This refers to the way it is related. Dimensional analysis. This refers to the way it is connected, associated, or related to the fundamental quantities, of mass, length, and time. This refers to the way it is connected, associated, or related to the fundamental quantities of mass, length, and time. I hope you are aware. This is what you will define for those of you who attend IMSU. This is the definition of what? Fundamental what? Sorry, dimensional what? Analysis, right? You have to know that dimension for mass is measured in kilogram. It's simply what? Capital M. Dimension for length in meter is capital L. Dimension for time in seconds is capital T. Meaning any quantities in physics that has the unit in kilogram has what? Capital M dimension. That of length is what? Capital L. That of time is what? In seconds is what? Capital what? T. All right. Now, another aspect I want us to take note under this dimension analysis is simply application. If you're asked to state the applications of dimension analysis, application, what are the applications? Number one is that it is used to check the correctness of an equation. It is used to check the correctness of an equation. Please, if you're active, indicate that you're active. If you're active, please indicate that you're active. It is used to check the correctness of any physical equation. It is used to check the correctness of any physical equation. Number two is that it is used to determine the homogeneity of an equation. To determine the homogeneity of an equation. When you said homogeneity, what does that mean? It simply means that an equation is homogeneous if all the terms in that equation have the same dimension. So the uses or application or the significance of dimensional analysis is also known as what? Significance of dimensional analysis. Number one is to check the correctness of a physical equation. Number two, to check the homogeneity of an equation. Number three, it is used to derive the relationship between different physical quantities. It is used to validate an equation. It's also used to convert units and derive units. It's used in converting units. So these are the applications, these are the uses, these are the significance of what? Dimensional analysis. Now I want us to solve a problem from your textbook already. I think we have already solved something like that before. By now, if you're asked to find the dimension, find the dimension of the following. First one, we have length. Number two, we have radius. Number three, we have speed. Number four, we have acceleration. Number five, we have force. Number six, we have pressure. Number seven, we have density. Okay, we have surface tension, etc. I'm going to stop here. Then you can use this knowledge to solve others. Then we'll solve another problem that have to do with deriving formula. Now, dimension for length. Any quantity measured in meter, don't forget, in meter has what? Dimension of L. In kilogram is what? Is capital L. But in second is what? Capital T. Don't forget. So dimension of length. Length is in meter. Dimension is what? Capital L. Radius is also in meter. Is measured in meter. Dimension is what? Capital L. Speed is distance over what? Time. Dimension of distance. Distance is in meter, which is L over capital T. Because time is in seconds. So that means it has what? Capital T. When you take this up, it becomes what? LT minus 1. Dimension of acceleration. Let me explain this. For speed is meter per second. Abi? Meter is capital L. Second is capital T, so minus 1, which is what we have here. For acceleration, what acceleration? Meter per second squared. Meter is capital L. Second is capital T, then minus 2. The next one is force. Force, we know, is mass times acceleration. Mass is in kilogram, Abi. What's acceleration? Meter per second squared. Any quantity measured in kilogram has what? Capital M dimension. In meter is capital L. In seconds, sorry, in meter, of course, capital L. In seconds, capital T. Then we have power of minus 2. Don't forget. Then that of pressure. Pressure is defined as force over area. Force already, we have already solved our force, which is M LT minus 2. Area is length times width. Dimension for area. Area is measured in meter squared, right? Meter squared. Volume is what? Area is meter squared. Volume is what? Meter cube. Don't forget. So area, since area is in meter squared, that means it's going to be L squared, right? Okay. From here, one of these lengths can cancel this. So pressure becomes what? MT minus 2 divided by what? L. So by the time we move this up, pressure becomes M L minus 1 T minus 2. So this is dimension for pressure. Pressure and stress of a material have the same dimension. Pressure, stress, and Young modulus have the same what? Dimension. Please take note that pressure, stress of a material, okay, and Young modulus have the same dimension. The next one is density. Is density? Is density? What is density? Density is mass over volume. Mass is in kilogram. Volume is in meter cube. Don't forget that volume is in meter cube. So that means our pressure becomes kilogram is capital M, meter is capital F to the power of 3. By the time we take this up, this becomes pressure equals ML minus 3. Are you there? Okay. So the next one is called sorry, this is not pressure, this is density. Density is mass over volume. Mass is in kilogram, volume is in meter cube. So kilogram is what? Capital M. Meter cube is what? L cube. So volume, so here becomes density become, which is mass over volume. By the time we move this up, become ML minus 3. So this is for density. This is for density, right? This for density. Let me use the other for density. This density. Okay. This is our density. Okay. Now the next is surface tension. Surface tension is force per unit length. That's surface tension. Or I can say force over length, right? Force over length. Force. We have already solved for force. The measure for force is kilogram. Force is mass, right? Times acceleration. Length, we have over length, right? Okay, let's go on. Dimension, our unit of mass is kilogram times acceleration is what? Meter per second squared divided by length is what? L, right? So the dimension for in kilogram is capital M. That of meter is L. That of second is capital T minus 2 divided by what? Capital L. And L cancel L from here. So surface tension is what? Capital M T minus 2. This is the dimension for surface what? Tension. For surface tension. Right? Okay. Now there's a question I want us to solve in the textbook. The question says, consider a simple pendulum of mass M. Please take note of this question. I will take my time. I will take it easy while solving this. Although in my class on dimension analysis, I solved this question before now. I don't know if you guys can still remember. Let me detect the first. Let me detect the question for us to see. Then we'll proceed from there. Consider a simple pendulum of mass M suspended from a long thread of length L. If the period of oscillation of the pendulum is given by this, if the period is given by Km to the power of X, L to the power of G to the power of Z, we also find the value of X, Y, and Z. We are told that M represents the mass, L represents the length of the pendulum rope, then G represents acceleration due to what? Gravity. Please, if you are following, please indicate that you are following. Indicate that you are following. Please indicate that you are active. Indicate. Okay. Now, what do we need to do? We need to find, since we have to find the unknown, which are X, Y, and Z, we have to find the dimension of each of these first, okay? The dimension, solution, the dimension for period, capital T. Period is measured in seconds. Dimension is what? Is T capital T. Don't forget, period means the time taken to complete one oscillation. All right, that's period. So it's a time taking. So that means that period will definitely have the same dimension of time, which is what? Capital T. Because period is measured in what? In seconds. So the dimension for K, the next quantity is 1. Every constant has dimension of 1. Take note. If I have 2 pi, if I have 3 pi, if I have any constant, 8, 9, 2, their dimension is what? Somebody is 1. Take note of this. So dimension for mass is in kilogram, don't forget. Dimension is capital what? M. Dimension for length is in meter, is capital what? L. Dimension for G is in meter per second squared. Don't forget, G means acceleration due to gravity. That means G have the same dimension as what? Linear acceleration, which is what? Meter per second squared. And that will give us what here? Meter is L, right? Then T to the power of what? -2. Now we have successfully bring out the dimension of each of these physical quantities. Now let's put back their dimension here. But we are given, right? We are given that period is equal to what? Km to the power of X, L to the power of Y, G to the power of Z. So dimension for period is capital T. For K is a constant. Our answer is 1, right? Dimension for mass is capital M to the power of X. Already I have 1 here. I don't need to start putting 1. Although K is 1, you must not put the 1 to indicate that there's a 1 here, right? Coefficient of this M raised by X is 1. So don't need to putting 1 again. So dimension for mass is what? Is capital M. For this length is what? Capital L to the power of Y. Then for this G, that will give us what? Our G is LT minus 2. All to the power of the power here is what? Don't forget, the unknown here is what? Is Z. So to the power of Z. Now what do we do here is to evaluate it further. That will give us M with the power of X, L to the power of Y. By the time we split, there becomes L to the power of Z times T to the power of -2Z. So what happened here? M is this, right? L is this. This is to the power of Z. This Z is a power which is affecting L and T. So here, 1 times Z is what? Is Z. -2 times Z will give us -2Z. Are you there? So that means that from here, I can actually group this way. Here we have M to the power of X. I have 2 numbers that have a common base. I can pick one of these base and add up the power. Here become Y plus Z, right? Okay, Y plus Z. All right, so let's proceed further. Then here we have T to the power of what? -2Z. Now the next thing is to compare both equations, both sides of the equation. I'll compare both sides of the equation. If we are to compare, look at this. The dimension we have here are M, L, and T. Here we have T, right, to the power of 1. Either while comparing, I have to bring out all the invisible dimensions here. In as much as we have MLT, we equally have what here? M and what? L. But just that the power of M and L here is what is 0. If what we have here is just only, let's say L and T, that means I'll look for a means to generate what L and T. So for this side, we only have T. But for me to compare, I have to bring out my M here to the power of 0. Then what again? L to the power of 0. Reason because M to the power of 0 is 1. In indices, any quantity to the power of 0 is 1. Likewise, this is also 1. So 1 times 1 times T is still what? Is still T. So I have practically added nothing. I only bring out this and this just for me to be able to compare, right? So while comparing, I'll compare M with M. If I'm comparing M, look at this. M to the power of 0, M to the power of X. In indices, whenever two bases are the same, we can cancel the base and equate their power, right? That means my X is equals to 0. If I cancel this base, it means X equals to 0. That's the first one. Also, I can compare this. If I'm comparing this, L to the power of 0 equals to what? L to the power of what? Y plus Z. So the base are the same. I can cancel the base and equate their power. Also, we can say that Y plus Z equals to what? Equals to 0. Equation 1, right? I can also compare this minus 2Z to be equals to what? T. Minus 2Z from here, meaning that T is equals to T raised power what? Minus 2Z. Okay, this can go with this, right? The power here is 1, right? So that means that minus 2Z is what? 1. From here, I can find the value of Z. That means that my Z is minus 1 over 2. So if my Z is minus 1 over 2, so what do we do now? We have gotten Z as minus 1 over 2. We have to put Z equals minus 1 over 2 in equation 1. That says that Y plus Z equals 0. So here we have Y, okay, plus minus half equals to 0, right? So Y becomes, when you move this minus half to the other side, it becomes what? Half. Therefore, our X is 0, Y is half, YZ is what? Minus what? Half. This is just what we are looking for. The value of X is 0, Y is half, and Z is what? Minus half. That is just all. Sometimes you might be asked to find the expression connecting period, length, and what? And G. Find the expression connecting period, length, and G. Let me quickly do that. But if they say find X, Y, and Z, just stop here for them, okay? But if they say find the expression or the formula connecting period, length, and G, the formula, I will say form period equals to K, right? Mx Ly, then Gz. Our period becomes what? K. Our X is 0, right? Not forget. Our Y is what? Y is half. Then G is what? Minus half, right? Okay. So what do we do next is to evaluate further. We have K. M to the power of 0 is 0. So that will give us what? Yeah? L half. Okay. Over what? G half. Why do we say over G half? Because we have minus half here. When you have minus as a power, it becomes 1 over that number, right? So this is same as what? K root what? Root L over what? Root G. Don't forget, that is same as K. The word L half means what? L to the power of half means square root of what? L, right? Likewise, G, square root of G. There's a law that says sod A over sod B. The law says sod what? A over B. So that means my period becomes K. I can apply that law here. Sod L over sod G give us sod L over final answer. This you only solve this if there's a find the expression connecting period, length, and what? And gravity. So you have to bring it up this way. Next question, please, if you are following, indicate in the comment section. Following. Okay, guys, please do me a favor, share this link now to other people to join. Share. Ensure you share this link. Ensure. Please, there is no light. Just bear with me. that the board, some part of the board is not visible, right? Just bear with me. Just make sure you share this video. If you have shared this video, indicate in the comment section. Please share. Okay. I'm going to stop here. There are other questions I've done in my previous video under dimensional analysis. Just go to the EMI-BRAIN channel, click on the live video. You'll see the caption, dimensional analysis. Just go through it. With this knowledge, there are some other examples I solved, right? But basically, make sure you master this particular question. Master is like your life depends on it. Are you following somebody? So please take note of this. All right, the next question I want us to move into now is under vectors. Already we have defined vectors, right? It's under vectors. It's under vectors. We have defined vectors as quantities that have what size and direction. And we have seen the examples of vectors from this class. And I want us to take note of, there are some basic terms need to take note of in vectors. Number one is basic operations. We have addition and subtraction of vectors. We have unit vectors, addition and what? Subtraction. Number two, we have unit what? Vectors. Number three, we have angle between two vectors. Number four, we have what we call dot products of vectors, also called the scalar product. The next one we have is called cross product, also called the vector product. The next one we have is called scalar projection of two vectors. The next one we have is direction, cosine, and we equally have what we call resolution of vector resolution, okay, vector resolution of vectors and all that. All right, I will just go through this class and we'll just look at how we're going to solve a problem from here. Then after we are done with this, we move down to linear kinematics. We solve a problem under linear kinematics and under projectile and all that. So please take note of this. I'm going to give an example. Listen, example one. Okay, let me just take notes. Example one. Given vector A equals, okay, let me pick from your textbook. Just be patient a little. Let me get the question from your textbook. Okay. From your textbook, given that vector A equals 2I minus 3J minus K, and vector B equals I plus 4J minus what? 2K. Then we have to find the following. Number one, let's find our A plus B. Number two, A dot B. Number three, A cross B. Number four, please pardon me, excuse me, let me get the exact question. A plus B, A plus B, A plus B cross or times A dot B times A dot B. Number five, the angle between vector A and vector B. Number six, projection of vector A on B. Or let's take for unit vector first. Unit vector of vector A, projection of vector what? A on what? On B. Okay, I'm going to use this question to summarize everything I need to say. Under this topic. Let me add up again. Let me add up again and see what are we missing here. I think we are missing. Okay, we have already brought out angle between two vectors. Okay, let me add what we call area of a parallelogram. IX, area of a triangle, etc. Then the last question says prove that A dot B is equals to 0. A dot B is equals to 0. But this should be a separate question, not from this. Okay, so I don't really know if our dot product is 0. I will show us how to prove this. This should be question number 1. This number what? Number 2 is a separate question from this. Now, let's look at this very fast. The first one is addition. This is very simple. Every one of you should know how to add vectors. First one says 2i plus 2i minus 3j minus k plus I plus 4j minus 2k. All right, I plus 4j minus 2k. If I'm to add these two vectors, I add the means is like taking like terms. I'll add up 2i plus I. 2i plus I is 3i minus 3j plus 4j, now give us plus j, right? The minus k plus minus 2k is minus 3k. I'll repeat again. While adding, 2i plus I is 3i, minus 3j plus 4j is plus j. The minus k plus minus 2k is minus 3k. This is very simple. The number 2 says find A dot B. The word A dot B means find a scalar product. They might use the word find a scalar product of A and B. Or they might use the word find the dot product of A and B. When you hear the word find the scalar product of A and B, that means find A dot B. So that simply implies that our vector A is 2i minus 3j minus k dot I plus what? 4j minus 2k. So to find a scalar product, it means I will multiply the scalar value. The scalar I, j, k are called the unit vectors. So the scalar value of A are simply 2 minus 3 and what? Minus 1. If I, J, K are called unit vectors, what is remaining here is what? 2, minus 3, and minus 1. If I, J, K are called unit vectors, what's remaining here is what? 1, 4, and what? Minus 2. So I'll multiply these 2 with 1 here. Coefficient of I here is what? Is 2. Coefficient of I here is what? Is 1. So 2 times 1 will give us what here? 2. Then for the other one, minus 3 times 4, that will give us minus 12, right? Then the next one is minus 1 times minus 2 will give us plus what? Plus 2. Okay, is that clear? Now the next is to add up. So here we have 2 minus 12, that is minus 10, plus what? 2. The answer becomes what? Minus what? 8. So our A dot B is simply what? Minus 8. The next one is to find our cross product. When you see the word A cross B, this means cross product or vector product of A and what? B. All right. Please, if you are following, indicate that you are following. Indicate that you are following. Okay. Now listen. To find the cross product, what we need to do is to bring out the matrix form. I have to bring out the unit vectors. Meaning what is common between A and B is IJK, IJK. I'll bring them out here, I, J, and what? And K. The next is to bring out the scalar for A. Scalar for A is 2 minus 3 and what? Minus 1. We have 2 minus 3 and what? Minus 1. Scalar for B. Okay, let's proceed. Scalar for A is 2 minus 3 and minus 1. Scalar for B is 1, 4, and what? Minus 2. All right, so the next is, I would like to clean here just this question. Okay, let me clean this part so we can proceed. Now listen, to find this A cross B is a very simple one. To find this, I have to note that in the matrix, we have what we call invisible signs, right? Invisible sign. The first sign here is plus, minus what? Plus, right? Okay, we call this sign the minus. The minus. Here is plus, minus, and what? And plus, okay? Now what we're going to do is to bring out the cofactor of each of these minor. The cofactor of I is minus 3, minus 1, 4, and what? Minus 2. The cofactor of J is simply 2, 1, minus 1, and minus 2. The cofactor of K is what? 2, minus 3, 1, and what? And 4. Let me explain what I mean by cofactor. If I have a matrix, let's say I have A, B, and C, D, E, and F, G, H, and I. To find the cofactor of A, I have to circle this A and cancel every part here and every part here. We are left with what? E, F, H, I. To find the cofactor of B, I'll circle B, cancel here, and cancel here. We are left with what? D, F, G, I, right? To find that of what? C, I'll cancel here and cancel here. We are left with what? This, D, E, G, and H. Likewise, this, I'll do the same thing here. Okay, but take note that in each of these, we have our signs, plus, minus, and what? Plus. So the first one is what? Plus I. Plus I. The cofactor of I will circle here, cancel here, and cancel here. We are left with what? Minus 3, minus 1, okay? 4 and what? 4 and 2. The next is plus K. Plus K, that will give us, if I'm to find the cofactor of this, I will cancel here and here. We are left with what? 2, minus 3, 1, and what? And 4. Then the next is, sorry, plus, what will be here is minus sign. Why do we have minus? Because here we have minus. So this should be minus J, not minus K. Sorry for that. The cofactor, let's go again. We circle here, right? We cancel here and here. That will give us what? Okay, that means we omitted, we are too forward. Now listen, the cofactor of J means I will circle J, cancel here and here. meaning this, abi? That will give us 2, 1, minus 1, and what? Minus 2. Then followed by plus k. Plus k. This will give us the cofactor of plus k. I will cancel here and here, right? That will give us 2 minus 3, 2 minus 3, 1, and what? And 4. All right, so let's finish up this together. Please, if you are following, indicate that you are following. Indicate that you are following. All right. Now the next is A cos B. We're going to find the determinant of each of these. In mathematics, there's what we call, if I have A, B, C, D, this is a 2 by 2 matrix. We call this line the major diagonal. Major what? Diagonal. Also called the main diagonal. Right? This is called what? The minor what? Diagonal. So what do we do is to multiply the major, meaning A times D will give us what? AD minus B times C is what? BC. I will do the same thing in what we have here. I'll do the same thing here. I'll multiply minus 3 times 2 is what? Minus 6. You will say when you multiply the major, subtract, right? Minus 1 times 4 is what? Minus 4 in bracket. Then minus j in bracket. Okay, let's proceed. This will give us this will give us minus j. 2 times minus 2 will give us what? Minus 4. Then minus bracket. Minus 1 times 1 is what? Minus 1. Close the bracket. Plus what? K in bracket. 2 times 4 is what? Is 8. Minus in bracket. Minus 3 times 1 is what? Minus 3. Okay. Minus 3. So let's finish up this. So our A cross B becomes, here we have I in bracket, minus 6. Minus that minus is plus. Here becomes minus 6 plus 4. Okay. Minus j in bracket. Minus 4 plus 1. Okay. Then plus k in bracket. 8 plus what? 3. Let me explain what happened here. You understand what happened here? Minus and minus to give us plus. Minus and minus to give us what? Plus. Minus and minus to give us what? Plus. When we multiply minus by minus, the result is what? Plus. So here becomes minus 6 plus 4. Minus 6 plus 4. Minus 6 plus 4. What do we have here? I hope you guys are following. Please, if you are following, indicate that you are following. 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 I think there's a correction I want to check. Our vectors. Vector A is 2 minus 3 minus 1, right? Sorry. We have I, J, and what? And K. Vector A is 2 minus 3 and minus 1. Vector B is 1, 4, and what? Minus 2. Let me verify something. Vector A is 2 minus 3 and what? Minus 1. Vector B is 1, 4, and what? Minus 2. So the cofactor of this is this. There's a mistake, we omitted a sign here. Sorry for that. Here is what? Minus 2, not minus, not 2. I assume here to be plus. So please, there's a mistake here. This is minus 2, right? Okay. Let's verify that of J again. J, we cancel here and here. That will give us 2 minus 1, 1 and minus 2. Okay, correct? Then that of K, what do you have for K? 2 minus 3, 1 and 4. Okay, I think we are now correct. So that means that the challenge here is from this end, Abi. Minus 3 times minus 2 is what here? Is plus 6. Please take note, this is plus 6, okay? This is plus 6. That is plus 6. So plus 6 plus 4, that will give us about 10, right? Plus 6 plus 4. 6 plus 4 is 10. 10 times I is what? Is 10I. So here we have minus 4 plus 1 is minus 3, right? Minus 3 times minus j is what? Plus what? 3j. Then the next one will then be, what is 8 plus 3? That's 11. 11 times k is what? Plus what? 11 what? K. Please take note of this and take note of the correction. Okay? The sign here should be minus 2. when you mix your sign to affect your result, you have seen how it affected our result. So please, while bringing out the scalar for A, ensure you got the appropriate signs. All right. So the next question then says that we have solved for this, right? We have solved this, we have solved this. Let's solve for A plus B times A dot B. Here we have, the next question says, IV, A plus B times what? A dot what? B, right? So what we do, already we have already gotten our A plus B from the initial question. But let's solve it again. For A plus B, what we have? 2i plus I is what? Is 3i, right? Minus 3j plus 4j is minus what? Is plus j. That is plus what? Plus j. I'll repeat again. 2i plus I is 3i. Minus 3j plus 4j is what? Is plus j. Minus k plus minus 2k is what? Minus what? 3k. We are told that this is multiplied with what? A dot B. What do we solve as A dot B? We solve A dot B as minus 8, right? Our A dot B, I've already cleaned the board. Please note, recall that A dot B is what? Minus 8. So what do we do here? Here becomes what? Minus 8. So that means I'm going to multiply the whole of these vectors here with what? Minus 8. Then when we multiply that, what will be the result of the vector? That will give us 3i times minus 8 is about, that will give us about minus 24i, all right? J times minus 8 is what? Minus what? 8j, right? Okay. Then minus 3k times minus 8 is what? Plus what? 24 what? Okay. Final answer to this. Don't forget that after adding A plus B, we have this. Then in our previous example, which is under A dot B, our answer is what? Minus 8, right? Then that means minus 8 times this give us what we have here. And how do we get it? We have to expand. Minus 8 times 3i is what? Minus 24i. Minus 8 times j will give us what? Minus 8j. Minus 8 times 3k is what? Minus is what? Plus what? 24k. Because minus times minus is what? Is plus. So 8 times 3 is what? 24k. Good one. We have solved. The next part says that find the angle between A and B. The angle between A and B. The angle between vector A and what? And vector what? B, right? For the angle between A and B, the formula says what? Formula says cos theta equals cos theta equals A dot B over what? A modulus times what? B what? Modulus. A dot B over A modulus times what? A modulus over what? So A dot B over A modulus times B modulus. Already recall that A dot B is already giving us what? Minus 8 from our calculation. Our A dot B is minus 8, right? From our calculation, okay? If A dot B is minus 8, so what do we do? Is to find, let's find our A modulus. Modulus of a vector. In our previous class, modulus simply means if vector A is Si plus Yj, modulus of A simply means square root of S squared plus what? Y squared. So modulus of A will be, since vector A is a 3D vector, the first is what? Our S is what here? As S squared. Then our Y is what? Minus what? 3 all squared plus, here we have minus what? Minus 1 all squared. And that will give us A modulus, which is equals to what? 2 squared is 4 plus minus 3 squared is 9 minus 1 squared is what? Is 1. So our A modulus is simply square root of 9 plus 1 is 10 plus 4. That is 14. Now the next is to find what? B modulus. What is our B modulus? Meaning what? 1 squared plus what? 4 squared, right? Plus what? Minus what? 2 all squared. Is that clear? So B modulus will then be square root of what? 1 square is 1, 4 square is 16, minus 2 square is 4. I repeat again, B modulus will be 1 squared plus 4 squared plus minus 2 squared. And 4 plus 16 plus 4 is 20 plus 1. What do we have here? With what? With 21. With what? With 21. Okay, so the next is to determine the angle between the two vectors. The angle between the two vectors. Let me in this part. The angle between the two vectors will then give us cos theta equals to our A dot B. But after all of this, you continue with this. A dot B, that will give us minus 8 over root. A modulus is what? Root 14 times B modulus is what? Root 21. Okay, root 14 and root 21. Let's see what they're going to have at the end of the day. Let's see, we have 14 times 21. This will give us minus 8 over root 294. Square root of root 294, that will give us our cos theta equals minus 8 over 17.1464. And this will give us minus 8 divided by 17.1464. Our answer becomes minus 0.4666. Okay, 4666. Okay, okay. So that means our cos theta will then give us, or rather, our theta becomes cos inverse of minus 0.4666. So let's go. Shift and cos inverse of minus 0.4666. All right, give us about our theta equals to 117.81814 degrees. That is the angle between the two vectors. Now, another way you can solve this, I always tell students, is that you can actually ignore the sign. When you ignore the sign, shift and cos inverse of 0.4666, right? 666. Excuse me. Shift and cos inverse of 0.4666. This will give us about 1862. Then you check in your Cartesian diagram where your cosine is what? Negative. You have to check in the Cartesian diagram. We have what we call O. Here is cast, S and T. Here, our cosine is negative here. That means that the angle here is what? Is 180 minus what? Minus theta. So if at the end of the day, I ignore this sign and I just find my theta to be cos inverse of 0.4666, the answer we have is about 62.1862. Okay? Now, because I ignore the sign, I will then come to my Cartesian diagram and ask myself, where is cosine negative? X means only sine is positive. T means only tan is positive. Cos means only cos is positive. So that means my cosine is negative here. So I can just subtract this angle here. So I will say minus 180. This will give us about the angle, our theta, is still 117.81814. Are you guys seeing it? But in the exam, instead of going through this whole process, just find the cos inverse of minus 0.4666, and that will give us what? 117.814. Or if you can ignore the sign, but if you ignore the sign, any value you have here is not the angle. You have to check it out in your Cartesian diagram. Where is the cos of that angle negative, which is what? In the first quadrant. Okay? Or better still, for simplicity, for the sake of simplicity, just find the cos inverse of minus 0.4666. That will give you the direct answer, which is the angle between two vectors. Now, the next one says, these other ones, I will just list out their formula. Then we can move into something else, okay? The next one, question 6 says, find the unit vector. Unit what? Vector of A, or unit vector in the direction of A. Unit vector is given as A cap equals to vector A over what? A modulus. This is the formula for finding unit vector. Unit vector it simply means a vector that has magnitude of what? Of 1. Of what? Of 1. Okay? That's what we mean by unit vectors. Unit vector, these are vectors with magnitude of what? Of 1. Alright? Like we have our I, J, K. Magnitude of I is what? Is 1. J is what? Is 1. K is what? Is 1. Even if I have this, I have a vector A equals to this, I can find the magnitude of my unit vector. At the end of the day, the answer must be equal to 1. But that is not what I'm proving. Let's just solve for this, okay? So unit vector of A simply means vector A. Vector A, alright? Vector A. Vector A is what? Is 2I minus what? 3J minus what? K divided by modulus of A is sod 14, have you? Sod what? 14. That's modulus of A. And sod 14 is about, so we have A, unit vector of A becomes 2I minus 3J minus K divided by 3.7417. Alright? Now what you need to do for me, because I won't go into this, divide 2I by 3.7417. Write the answer here. Minus, divide 3J by this. Okay, divide minus K by this, then put the value. So your final answer should be in decimal. So that will give us 0 point something I minus 0 point something J minus 0 point something K. Is that clear? Okay, now the next question says, find the projection of vector A on B. The projection of vector what? A on B. The projection of vector A on B. Of A on what? On B. The projection of vector A on B is simply defined as vector A dot unit vector of B. Projection of vector A is called scalar projection of vector A on B. Meaning at the end of the day, your answer must be a scalar value. So is given as A dot unit vector of A. If they say find a projection of vector B on A, that will be what? B dot what? Unit vector of what? Of A. But the question says find the projection of vector A on what? On B. It's actually on B, not on A. So that means that the formula says what? Vector A dot unit vector of B is what? B over what? B what? Modulus. Unit vector means that vector over the modulus of that vector. So that will give us what here? A dot what? B over what? B what? Modulus. A dot B over B modulus. Okay, already we have already gotten our A dot B. What's our A dot B? Minus 8. What's our B modulus? Square root of what? 21, right? So what we do now is to evaluate further. Okay, we have to find the square root of this. Divide this by this. That will give you the final answer. Or we can say the answer is minus 8 with 21 over what? 21. What we did there is to rationalize, Abi. We rationalize. All right, that gives us this answer. Or you can just divide 8 by the root of this. That will give you your answer in decimal. Or you can leave your answer in this format. Okay, the next question says find the area of a parallelogram. I'm not going to go into this. I'll just give you the formula for the area of a parallelogram. The area of a parallelogram is given as A cross B modulus. Area of a parallelogram is what? A cross B modulus. That's the area of a parallelogram. Meaning that after finding our A cross B, although I think we have already gotten our A cross B, let's just go straight to the point. Let's go to the point. Recall that A cross B is given as what? 10I plus what? 3J plus what? 11K, right? So that means that modulus of A cross B, that is the area, right? Meaning modulus of 10I plus 3J plus what? 11K. What the modulus? Modulus means what? The resultant, Abi. That will give us what? 10 square plus what? 3 square plus what? 11 square. So please do me a favor. You know what to do here, right? What do? Find, okay, that will give us our 10 square is 100. This is 9. 3 square is what? It's 9. 11 square is 121. So when you add up this, find the square root. That will give us the area of the parallelogram. Then the next one says area of a triangle. Area of what? Of a triangle. Area of a triangle is also same as, is given as rather, modulus of A cross B divided by what? By 2. Modulus of A cross B divided by 2. That's the area of a triangle. Meaning that any value you have here, divide that value by 2. That will give you what? The area. Next question. I want to believe that you can differentiate between scalar and vector. I've already mentioned that before. Next question is a question under projectile motion, and I'll be very fast in this question. I would there somebody? Next question. A question under projectile motion. By now, you should know what is a projectile, right? I've defined projectile before in this class. So projectile is a body. Projectile is not a process. It's not a motion. Projectile is a body in which, when launched into the air, moves in a parabolic path under the influence of gravity. That is a projectile. A projectile is a body in which, when launched into the air, moves in a parabolic path under the influence of what? Gravity. And we have examples of projectile motion. Examples of what? Projectile motion. Number 1, a kicked football. A kicked what? Football. Number 2, a bullet fired from a gun. A bullet fired from a gun. Number 3, an athlete performing a long jump. An athlete performing a long jump. The next one is a play tennis. When you play a tennis, that's an example of projectile motion. Number what? The next one, a stone thrown horizontally from a cliff. When you throw a stone horizontally from a cliff is an example. Then the next one, a basketball thrown upward, thrown towards the hoop. Thrown towards the hoop. Are you there, somebody? Thrown towards what? The hoop. Now, there are some certain terms in projectile you should know by now. The first one is called the time to reach the greatest height, right? Time to reach the greatest height. Number 2, we have time of flight. Number 3, we have maximum height. Number 4, we have range or horizontal what? Range, right? And so on and so forth. Then we also have what we call the trajectory path. This is the path the projectile followed, the path the projectile moved. It's called the trajectory word path. Then the first one I mentioned is called time to reach the maximum height. Maximum what? Height. The formula says T equals to what? U sine theta over G. Number 2 says time of flight. Time of what? Flight. The formula says T, right? And that will give us what? 2 times small t, which is 2u sine theta over what? Over G. The third one says what? Horizontal distance or range. Range is given as ROS equals to what? us times time of flight, or range is given as u square sine 2 theta, right, over what? Over g. The next one is called the maximum height. Maximum height is given as u square sine square theta divided by 2g. These are the terms. Time of flight means the total time taken, the time taken for the body to move from the point of projection to the point where the projectile hits the projection plane. That's called time of flight. The next one is called range or horizontal distance. Range is defined as the horizontal distance covered, right, from the point of projection to the point where the projectile hits the projection plane. When you hear the word range means horizontal distance traveled or covered by a projectile. It's called what? Range. The maximum height means the highest vertical distance attained, okay, as measured from the horizontal projection plane. The highest vertical distance attained as measured from the horizontal projection plane. From the what? Horizontal what? Projection plane. These are the basic terms you should note in, to take note of in projectile. Then in our previous class, please, if you have not watched that video, please ensure you watch that video. I did a full class on projectile a few days ago, and I said there are some fundamental assumptions, right? Fundamental assumptions, which I will use to solve the problem now. Assumptions. The first fundamental assumption I make mention of is that air resistance is negligible, right? Air resistance is what? Air resistance is negligible. And this has an implication. If we are saying that air resistance is negligible, if I have a projectile, let's say the body is being projected this way, right? The body is the pathway, the body moves. This is our initial speed, right? In meter per second. This is the angle of projection or angle of elevation, right? This speed here can be resolved into two components, which are uy and what? And ux. Our angle is here. The horizontal component here can be resolved as us equals to what? U cos theta. While the vertical component here, uy can be resolved as what? U sin what? Theta. All of this I explained in the previous class. Okay, why do we say us is U cos theta? Because the angle of inclination is along the s-axis. So while resolving this speed along the s-axis, us becomes what? U cos theta, while uy becomes U sin theta. Okay, now there are some fundamental assumptions under projectile. The first assumption is that air resistance is what? Negligible. If we are saying that we are neglecting what? Air resistance, as this object is moving, that means that the object as it's being projected is not affected by what? Any air resistance. Okay, no matter the wind, it's not affected by it. That means that horizontal acceleration is equals to 0. It means the body is only moving vertically, because if we are putting in consideration air resistance, that means that as the body is being projected, there's an influence of air on the body that is adjusting the body along the horizontal axis. So since I'm ignoring air resistance, it means that the body is only moving vertically. It's only accelerating vertically, rather. It's accelerating vertically. So since air resistance is negligible, that means our horizontal acceleration is equals to 0. And that also means that vertical acceleration is equals to minus g, because as the body is going vertically, there is always a force of attraction, a force of gravity that tends to oppose the motion of the body, because g is opposing the body as it's moving. So our ay becomes what? Minus g. So if this is equals to this, what is the implication here? It means that our Vs is equals to what? Our Us. Vs simply means final velocity along the horizontal component must be equals to what? Initial velocity along the horizontal components. That means that if the body moves with this speed, us, from the start, let's say for example 20 meters per second, it means that that same body will land with that same speed as well, 20 meters per second. Okay, that is the implication of neglecting what? Air what? Resistance. Number two assumption is that gravity is constant and it is always directed toward downward. Gravity is constant and is directed what? Downward, which is what we have seen here. Our AY is what? Minus what? G and all that. So these are the two fundamental assumptions that we considered in our last class. And I was able to show us something very fundamental. Please listen, because I will solve a problem with this right now, right now, right now. Please pay attention. From the equation of motion, hello guys, please, if you're active, indicate you're active. I don't know what happened. My phone just got disconnected by itself. My phone just got disconnected. I think we stopped somewhere here. From here, right? That if we are neglecting air resistance, AX is equal to 0 meter per second, AY is minus G. All of this I've discussed in the previous class when we learned projectile motion. Then from the equation of motion, that V equals to U plus AT. If I'm to consider the horizontal component, that means I'll put my Vs here equals to US plus AST. That means that here becomes US equals to US plus AST. Don't forget that because we are neglecting air resistance, AS is always 0. So that means if I'm to put 0 here, 0 times T will give us what? 0. So that means Vs equals to US. But note that US is U cos theta. So that means U cos theta equals to what? U cos what? Theta. Then for the vertical components, if I'm to use the same equation, here will be Vy equals to Uy plus what? Ayt. But don't forget that we say that our AY is minus G. Then here becomes Uy minus what? GT. Alright? Because we are neglecting air water resistance. Then in the second equation of motion that says S equals to UT plus RKT squared. For the horizontal component, this S will now be represented with what? With X here. I will represent this S with this X here to form, here will be what? UST plus half AST squared, right? Because we are neglecting air resistance, the value of our AS is still 0. So that means our AS becomes UST because AS times 0 times T squared times half is 0. So we are left with what? X equals to what? UST. For the vertical component, Y equals to what? UT, UYT plus half AYT squared. AY is minus G. So here becomes minus half GT squared. Now let's solve a problem from your textbook. Let's solve a problem from your textbook. This question will likely appear in your exam. In our previous class on projectile, we solved this problem. I don't know if you guys are already aware. The question here says, let's solve one of these examples. It says a projectile is launched with a speed of 50 meters per second. A projectile is launched with a speed of 50 meters per second at an angle of 40 degrees above the horizontal. At an angle of what? 40 degrees above what? The horizontal. Ignoring the effect of air resistance. Ignoring the effect of air resistance. Determine, the first question says, find the maximum height. The maximum height. Question B says, find horizontal range. Question C says, find the displacement. Displacement. And II, velocity. Velocity. of the projectile 2 seconds. 2 seconds, it is launched. 2 seconds, it is what? It is launched. We have solved this before. I'm going to repeat it again because this might likely appear in your exam. If you go to the first class we had, please, every one of you, you still have enough time this night. Go to all my lectures on YouTube. Go to projectile. I did a full class on projectile, and I solved some problems. We equally solve this example as well. Okay, this particular example was solved, but I want to repeat again. Okay, now listen. We are told that our speed is this. This is the projectile motion pathway, right? The speed is 50 meter per watt second. The angle there is 40 degrees. Where we have our maximum height, which is our H maximum, right? Maximum height is this. And we have to find the maximum height. Maximum height formula says what? U squared sine what? Square theta divided by what? 2g. I'm going to use this to find my maximum height. Okay, so maximum height here is going to be our u square. Our u is 50. 50 square sine square theta means sine 40, sine theta all squared, right? All divided by 2 times. We are told that g is 9.8. G is 9.8. So if g is 9.8, let's evaluate further and see what we're going to have at the end of the day. Our H maximum, 50 square is about 2,500. Sine 40 all squared is about 0.4132. Look for sine 40, then square it. That will give you this value. Divided by 2 times 9.8 is about 19.6. So H maximum, when you divide this, multiply this with this and divide by 19.6, this will give us about, okay, about 52.70 meter or 770 meter. This is my maximum height. Number, the B part says, find the range. Find the range. Find the range. The range here means horizontal range, right? Which is equals to what? U squared sine 2 theta divided by what? G. Our range is U squared sine 2 theta divided by what? G. Please, if you are following, indicate that you are following. Okay. So the range of this value becomes what? R equals to what? Our U is 50 squared sine 2 times theta is 40, all divided by 9.8. Okay. So what we do is to evaluate that, right? By the time we evaluate that, what we have at the end of the day, this will give us our range equals to 50 squared is about 2,500 times, okay, 2 times 40 will give us what here? Sine 80 divided by 9.8. So this will give us 2,500. Sine 80 is about 0.9848. 0.9848. When you find sine 80, that will give us this, divided by what? 9.8. Now, when you multiply this with this, divide by 9.8, our range here, horizontal range is going to be about 251.22 meter. 251.22 meter. This is our range we are asked to find. Then the next questioner says that we should calculate the displacement and velocity of projection. 2 seconds, it is launched. Calculate the displacement and velocity. 2 seconds, it is what? It is launched. So 2 seconds, it is launched. Let's find the displacement. Displacement formula say US, right? S rather equals to UT plus what? Half AT squared. I've already taught us how to find displacement. To find displacement, all right, what do? We have to find our horizontal displacement first. Horizontal what? Displacement. Displacement. And that will give us x equals to what? UXT plus half AXT squared. Is that clear? Don't forget that since we are ignoring air resistance from the problem, it simply means that our AX is equals to what? 0 meter per second. So that means our x here will be what? US times what? T. So our s becomes, our US is U cos theta times T. So that will give us x equals to, our U is 50 cos 40 times, our time is 2 seconds times 2. So this will give us our horizontal what? Displacement. Okay. So when you evaluate this, the value of x should be about 76.6, 76 point what? 0.60 meter. That's the value of our x. So the next question, the next part is to find the vertical displacement. The vertical what? Displacement. Vertical displacement. And that is our value of y equals to, here will be what? Uy t. Here will be minus half gt squared. Don't forget that if I'm to put our uy here and ay here, ay is equals to what? Minus g. So here will give us minus half gt squared, right? So that means my vertical displacement becomes, our uy is actually u sine theta times t minus half gt squared. So the next is to put in our values, right? To put in our values. So that means our y becomes, our u there is 50 sine 40, right? Times 2 minus half times 9.8 times what? 2 squared. 2 squared. All right, that's our y. Then, so what we have here at the end of the day, what do you have for y-axis? Okay, let's see what we are going to have here. At the end of the day, when you evaluate this for me, the value of y should be about 44 point what? 0.66 what? Meter. What do you do? Just find sine 40, multiply with 50, multiply with what? With 2, this times 2, right? This times 2, multiply with 2, then look for 2 squared, multiply it with what? 9.8 divided by 2, then subtract everything you have here minus this. The answer should be about 44.66. Okay, but we have to find displacement. Therefore, what then is our displacement? The first thing is to, represent. You have to represent displacement in vector form. In what? In vector form. Displacement in vector form is simply value of r equals to xi plus what? Yj. So displacement becomes what? Our x is about 76.60 meter, 60 I, plus our y is about 44.66 j. All in what? All in meter. Then when you replace this, when you put this in vector form, we then find the resultant of this vector. Resultant, the same way we find resultant for a vector, the same way, square root of what? S squared plus what? Y squared, meaning 76.60 squared plus 44.66 what? Squared. So what do you do for me? Find the square of this plus the square of this, then find the square root of their sum. Alright? When you find the square root of their sum, okay, then any result we have here is our displacement. Or let's find it together. Please, if you are with me, say you are with me. Let's find that together. Let's find that together. $76.6. 76.6. This is about square root of 5867.56 plus 44.6. 44.6 squared. This is about 1989.16. So let's add up these numbers. 5867.56. When you add up this, just add up this for me, then find the root of this. That will give you the final answer. Now let's move down to the velocity now. The next question says also find the velocity, right? Also find the what? Velocity. Velocity is given as what? From here, we can use our V. Okay, V equals to what? U plus what? AT, right? V equals to U plus AT. So from our horizontal velocity, don't forget that we say Vx is equals to what? Ux, right? So that means our Vx is same as what? Us is what? U cos what? Theta. Don't forget that you say for horizontal velocity, Vs is equals to Us. Why is it Us? From here, if I'm to put my Vs here, Us here, As here, because we are neglecting a resistance, we say that As is equals to 0. So 0 times T is 0. So that means Vs equals to Us. But Us is what? U cos theta. So what is the value? What we have here as Vs? Our U is about 50, right? Cos what? Cos 40. 50 cos 40. That is our value for Vs. 50 cos 40. Let me find out. Okay. 50 cos 40 is about 38.30. 38.30 meter per second. The next is to find what now? Our Vy, right? From here, what will be here? Vy equals to what? Uy minus what? Gt. Is that clear? Because for this, Ay will be what? Minus G. From here, so that means our Vy is going to be Uy, we know is what? U sine theta minus Gt. So then my Vy becomes 40 sine, 50 rather, 50 sine 40 minus 9.8 times our time is what? Is 2. Our time is 2, right? Our time is 2. So what do we have at the end of the day? We want to have here as Vy equals 1,550 sine 40, okay, minus 9.8 times 2 will give us about 12.52. 12.52 meter per second. Then the same thing we did here, that after we got our displacement x and y, we have to represent in vector form, right? I have to represent in what? In vector form. So in vector form, our V is what? Vsi plus what? Vyj, right? Okay. So that means our V becomes our Vx is 38.30I plus 12.52J, all in what? Meter per what? Second. Then the resultant of this vector becomes what? Becomes 38.30 all squared plus what? 12.52 all squared, right? And that will give us a value which is about 40. Our V becomes about 40 points. When you square this, then find the total square root, about 40.29 meter per what? Second. But one thing you should take note is that after getting this, we have to find a direction. The what? The direction. The direction of V, both I and J are positive. So I can just use tan theta equals to what? Equals to Vy over what? Vx. Vy over what? Vx. So if I have my diagram this way in the first quadrant, my Vy is here, right? My Vs is here. So that means my Vy over Vs. Because tan theta is from the word opposite over what? Adjacent. Abi? What's the opposite? Vy. What's the adjacent? Vs. So what do we do now to find tan theta? That will give us our Vy. We got, which is 12 points. Vy is what? 12.52. Our Vs is 38 point what? 30. So when you evaluate this, tan theta becomes what? When you solve this and find the, and that goes about 0.32269. So from here, therefore, our theta becomes tan inverse of this. That will give us about 18.1. Theta is about 18.1 degree. Please take note of this. Theta is what? 18.1 degree. That's our theta. 18.1 degree. Now let's solve other questions that I came across. This is just a recap. We have done it before. Go back to my YouTube channel on Projectile. It's still active. It's still on my channel. You can always go back there and have access to them. Okay, 9.8 is the standard. Okay, you are correct. All right, but in case you are given 9.81, don't tell them that is the standard. Someone is saying that 9.8 is the standard from the comment section. So if you are given 9.81, you tell them that 9.8 is the standard, right? Our next question here says, that's under collision. Collision. Please, if you are active, indicate that you are active. Some of you should miss our night class tonight. This class will be very intensive tonight. Don't miss it for anything. All right. The next question says that an object 5 kilogram moving with a speed of 60 meters per second collide with another body 3 kilogram moving with a velocity of 20 meters per second in the opposite direction. If after impact, the two bodies unite and move with a common velocity, calculate the loss in kinetic energy. Well, this is quite lengthy, but let's see how we can do it. In our last class, we talked about collision, that we have different types of collision. Please, I hope you guys are still active. If you are still active, please indicate that you're active. We have different types of collision. Types of what? Collision. I'm not teaching this actually, but I'm just recapping. We have elastic collision. Elastic what? Collision. Number 2, we have inelastic collision. Number 3, we have completely inelastic what? Collision. We say that for elastic that coefficient of restitution E is equals to 1, right? For this, our E is between 0. E is 0 is less than E, less than 1. Why for this, our E is equals to 0. Okay? For elastic, the value of our E is 1. E represents what? Coefficients of what? Coefficient of what? Restitution. Restitution. Okay. And the formula says E equals to what? V2 minus what? V1 over U1 minus what? U2. Is that clear? Where V2 is equals to, where V2 represents final velocity of the second body. V1 represents final velocity of the first body. U2 represents initial velocity of the second body. U1 represents initial velocity of the first what? Of the first body. Exactly. So all of this we have discussed so far. So please take note of this. And we say we have 3 types of collision. And I've defined them. Elastic means both energy and momentum are conserved. So E equals to 1. When we talk about inelastic, it means what? Momentum is conserved, but small amount of energy is lost. When we talk about completely inelastic, it simply means that momentum is conserved, but large amount of energy is lost. A good example of elastic is collision between gas molecules. Example of this is what? Car crash, when 2 cars collide or crash together. Then under this, we have a bullet fired into a block of wood and embeds into it. That's called completely inelastic collision. Okay, but this is not where I'm going to. The question here says that an object 5 kg moving with a velocity of 60 meters per second. An object 5 kg. Let's solve this problem together. An object of mass 5 kg. Mass is 5 kg. Moving with a velocity of our M1 is 5. Our U1 is 60 meters per second. Okay, collides with another body of mass 3 kg. Our M2 is 3 kg. Our U2 is about 20 meters per second. We are told that both of them are moving in different directions. Okay, in different directions. Then, if after impact the 2 bodies unite and move with a common velocity, okay, find the kinetic energy before it strikes the ground. Sorry, find the KE loss, the energy loss rather. Now we are told that both bodies collide and move with a common velocity. That simply means completely inelastic collision. A good example, like I gave, a bullet fired into a block of wood and embeds into it. So both the wood and the bullets move with a common velocity. So when you hear the word common velocity, that simply means completely inelastic collision. And what happens there is that the value of our E is equals to what? Equals to 0. E is equals to 0. All right? That is completely inelastic. So please, if you are following, please indicate that you are following. Indicate that you are following. All right, so let's solve this problem. I'll be very fast with this so that we can move to another question, because I've solved something like this in my previous class, right? In our previous class already. Now what we do is that we have to bring out, we are told that this is M1, right? M1 is what? Is 5 kilograms. This collide with what? Another body moving in different direction. The speed here is U1 is what? Is 60 meters per second. Our speed here, U2 is what? 20 meters per second. And the mass here is 3 kilograms. Then if after impact, they now unite and move with a common velocity. So that means we have here, my M1 is 5, my 5 kg. Here we have 3 kg. Now, momentum is conserved. Among the three types of collision, one thing is common, is that momentum is what? Is conserved. So if it's conserved, and that means that for M1 U1 minus M2 U2 equals to M1V plus what? M2V. Momentum is conserved. Momentum of the first body. Momentum means mass times what? Velocity. What happened here is before collision. This is before collision. This is what? After what? After collision. So before collision, the body moves with initial speed. So the speed here is for this is U1. What's the mass here? M1. So momentum here is called initial momentum of the first mass. This is called what? Initial momentum of the second mass. But because they are moving in different directions, that simply means that I'm going to put my minus sign here. Exactly. I'm going to put my minus sign there. Please, if you are following me, indicate that you are following. If you are following, please indicate that you are following. Okay. So let's finish up this. So our M1 is 5 times U1 is 60 minus our M2 is 3 times U2 is 20 equals to what? Yeah, we're going to have here to be M1. Okay, let's go. Our M1, I can just say, let me evaluate something for that. We have M1 U1 minus what? M2 U2 equals to, what is common here is V. We have M1 plus what? M2, right? Or I can just put the V here, right? Okay. So our M1 is 5 times 60 minus 3 times 20 equals to what? 5 plus 3 times V. So 5 times 60 will give us what? 5 times 60, okay? Hope you guys are following. We're going to have here to be about 300. 5 times 60 is 300. Minus 3 times 20 is 60. That is our 60. Equals to 5 plus 3, that is 8V, right? So 300 minus 60, that will give us about 240 equals to what? 8V. So to find V, I have to divide both sides by what? By 8. By what? By 8. So my common velocity is what? Is 30 meters per second. When I divide this with this, the result is what? 30 meters per second. Now the next is to find the energy loss, right? The energy loss. Energy loss is very simple to calculate. Energy loss we are looking for here is our KE loss, right? Energy loss here is simply our KE. That means our KE loss is simply KE before collision minus KE afterwards, after collision. The kinetic energy before collision is greater than after collision. Okay, because there must be a loss of energy. So let's find our KE before collision. Before collision, we have this, right? So KE here will be, that will give us half M1 U1 squared. KE simply means half MV squared. So for this, the KE here is what? Half M1 U1 squared. What sign is here? Minus half what? M2 U2 squared. So KE before will then give us half times our M1 is 5, our U1 60 squared minus have our M2 is 3, our U2 is 20. So 20 what? Squared. All right. So let's punch calculator and see. KE before collision give us half times 5 times 60 squared, 3,600 minus half times 3 times 20 squared is about 400. Okay. So what do you have here? So what do we have at the end of the day? So we have 3,600 times 5 divided by 2. Sorry, excuse me. 3,600 times 5 divided by 2. This is about 9,000 minus 400 times 3. 400 times 3 times, divided by times 3 divided by 2 is about 600. So by the time we subtract this, we're going to have here to be about, 9,000 minus 9,000. So excuse me, 9,000 minus 600 is about 8,400 joules. 8,400 joules. KE before is about 8,400 watts joules. All right. KE before is about 8,400 joules. Okay. Now let's find our KE after. KE after. KE what? After. KE after. I think I needed to correct something here, guys. Okay, this is accurate. Our speed is what, 30 meters per second. So please, the sum of all the energy before collision should be addition. We are adding KE before collision minus what? That of what? After collision. So KE before collision should be sum of all the energies here. So here should be plus, here should be what? Plus, here should be what? Plus, here should be plus. So this should be about 9,600 joules. Sorry for that. The total energy experienced here is the sum of these individual energies, right? The energy of this plus that of this, that'll give us 9,600. Then KE after should be, this is our KE after, which is this, Abi. KE will be half, the sum of this mass is what? M1 plus what? M2, then times what? V squared. So our KE after is going to be half times our M1 is 5 plus 3 times our V squared. The common velocity we have here is what? Is about 30 what? 30 squared. So KE after is going to give us half times 8 times 900. So let's see what we are going to have at the end of the day. That will give us about 3,600. 900 times 8 divided by 2 is about 3,600. Someone might be saying, why are we using addition? Why are we using addition? We are looking for energy loss, meaning KE before minus KE what after. KE before is the sum of the energy between these two bodies. Exactly. This sign here is showing that this body is moving in different direction. So what we're going to have here for KE before should be plus, because I'm adding the energy here plus the energy here to give us the total energy. Okay, if you put minus sign here, it is very wrong. Okay, because this sign does not have any effect here. Okay, the only time we're going to put a minus sign here is if the two bodies are moving in different direction. So what we should have here is that the sum of the energy for this first object plus that for the second object, which is what we did here, the sum of the energy plus this, and that gives us 9,600. Then after collision, we have m1 plus m2v, meaning 5 plus 3 times what? Times v. So our Ke after will now be what? Half. The mass here is simply m1 plus m2, which is m1 plus m2, then times what? The square of this v. But this v represents what? Our common what? Velocity. And that will give us 5 plus 3 times 30 squared. And the answer is what? 3,600. Then what then will be our Ke loss? The loss of energy. Loss of energy will not be Ke before minus Ke after. Ke before is 9,600 minus Ke after is what? 3,600. So by the time we subtract these two, okay, minus this gives us about 6,000 what? Joules. About 6,000 joules. That's the result for this. Please, if you are following, please indicate that you are following. If you're active, please indicate that you're active. Thank you. Yeah, the answer is 6,000 joules. 6,000 joules. 6,000 joules. 6,000 joules. Thank you so much that you are following. I'm so grateful. Please don't make mistake here. I almost did. If not that I understand the principle of energy conservation. The energy before collision is the sum of the two individual energies there. We must have to add them up. These two must be added together to give us energy before collision. All right, so please take notes. Thank you. The answer there is 6,000. The next question we have, question 5, right? Question 5. Excuse me. The next question states Newton's laws of gravitation. In my last class under Kepler's law, I was able to state this. Most of you did not take notes. Please go back to the previous class we had on Kepler's law, okay, and gravitation. I state a law called Newton's laws of gravitation. Newton's law. Newton's what? Law of what? Gravitation. I will just repeat this. Then we extended this to what? Kepler's law, right? Kepler's law. I'm referring every one of you back to this. Kepler has 3 fundamental laws. The first law is called what? It's called law of orbit. Law of what? Orbit. Number 2 is called the law of area. The law of area. Law of what? Area. Number 3 is called the law of period. Law of what? Period. These are the 3 fundamental laws of Kepler's. A scientist called Johannes Kepler looked at the nature of planets, how planet revolves around the sun. Then he was able to give 3 laws to back up his claim that planet revolves around the sun in an elliptical orbit, as the sun as one of the focus, and that's called the law of orbit. The planet revolves around the sun in an elliptical orbit, as the sun as one of the focus. Then the law of area says equal area is being swept, is being moved in equal time interval. Equal area is covered in equal time interval. Please go to that video. Then law of period says the square of the period is proportional to the cube of the mean distance of the semi-major axis from the moon to the what, to the earth. Please go through that video. It's still in my YouTube channel. I really talk more on this. Then we're able to prove that the third law says t squared is proportional to what? Cube of what? Of the mean distance between the sun and the earth or other planets, right? Please take note of this. Go back to this and study this. The video is still there, all right? I'm not going back to this. So let me just state this. Newton's laws of gravitation, because these two, they are interconnected. There's a relation between Kepler's law and this and Newton's law. That relationship is in the third law called the law of what? Period. When you combine, there's two forces that must be combined together to give us the third law of period. So you must have to go through this, study this, then you can also study this. Now let me state, Newton's law of gravitation states that if two forces, he said that the force of attraction between two masses, M1 and M2, M1 and what? And M2 is directly proportional to the products of their masses and inversely proportional to the square of the distance between them. I repeat again, the law states that Newton's laws of gravitation states that the force of attraction between two masses, M1 and M2, is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. What that law is simply saying is that, let's say if I have, for example, I have two masses in space, that the force of attraction is proportional to the product of the two masses, M1 and M2, equation 1. That same force is what? Inversely proportional to what? To the square of their distance between the two masses. The square of the distance between the two masses. By the time we combine these two laws, that means our F is proportional to what? M1, M2 over what? Over R squared. This is equation 3. I can take off this sign and introduce a constant, which is F equals to what? G, M1, M2 over what? R squared. G is called gravitational constant, which is about 6.67 times 10 per minus 11 Newton meter square per kilogram square. 6.67 times 10 by what? Minus what? 11 Newton meter square per what? Kilogram what? Square. This is the law. If you're asked to state the law, after stating that law, please give this expression. Very important. If you just state the law without this expression, you might not get the full mark. Okay? You not get the full mark. Please, if you are still with me, say you are with me. Say you are with me. If you're active, just say you are active. If you're active, just say you are active. Okay. This Newton's laws of gravitation is not same as the laws of motion. I hope you are aware. It's not same as the laws of motion. Newton's law of gravitation is not same as the laws of motion. Newton's law of gravitation only connect force and the masses and the distance of separation between the two masses. For Newton's laws of motion, we have how many laws? We have 3 laws of motion. We have the law of inertia. Number 2, we have law of what? Of acceleration. Number 3, we have the law of action and what? Action and reaction. Action and what? Reaction. I'm going to state the law. The first law of motion is called the law of inertia. It states that every object will continue in their state of rest or of uniform motion in a straight line unless acted upon by an external force. Every object will continue in their state of rest or of uniform motion in a straight line unless acted upon by an external force. The second law is called the law of acceleration. The law says that the rate of change of momentum of a body is proportional to the applied force. The rate of change of momentum of a body is proportional to the what? Applied force. Meaning that F is proportional to what? mv minus u over what? Over t. When you take off this constant, this sign rather, here becomes F equals to what? Km v minus u over t. To define this force, I have to say K equals to 1. If K equals to 1, by definition, then F equals to what? mv minus u divided by t. Alright? You might be asked to prove that impulse equals to what? Change in momentum. To prove that impulse equals change in momentum. How do you prove that impulse equals change in momentum? If questions say prove that impulse equals what? Change in what? In momentum. In momentum. So what do we have here? I have to cross multiply. Force times time is what? Ft equals to what? mv minus u. Impulse we know is I. Is force times time is equals to what? mv minus t. So this is the proof that impulse is equals to change in momentum. But impulse have two definitions. Impulse can be defined as the product of force and time, or change in momentum of a body. Change in momentum of a body. So impulse, unit of impulse is simply force is Newton, time is seconds, right? Or since Ft is also impulse is also change momentum, it can also be what? Mass is in kilogram. The whole of this is what? Our speed, which is what? Meter per second. So either Newton seconds or kilogram meter per what? Per second. This is just all about this. Now the next question I want us to look at, it says that a body is thrown under work energy and power of, I hope I'm not too fast. I'm just trying to have a review on some things. Please take note of what we are saying here. Very, very important. Very, very important. Very, very important. Very, very what? Important. Okay. Now the next thing we need to talk about is under work energy and power. Work energy and power. Work is said to be done when a force causes a displacement, right? In direction of thought of that force. Work is said to be done when a force causes a displacement in the same direction of that force. Meaning that work is simply equals to what? Force times what? Displacement. Force times displacement. Work is also equals to F(r) cos what? Cos theta. F(r) cos theta. If I have a body kept on this surface and I'm to cause this body to move from one point to what? To another, what we do, I have to apply a force, right? Call the applied force. Exactly, somebody call the applied force. Okay, let's say this surface is a rough surface. That means that there must be a frictional force, a force of opposition. This is the mass of the body kept on a rough surface, and the applied force is acting on it. There is always a force of opposition between the two, between the body and the surface, right? But if the body is applied in this direction, this is my direction of what? Of motion. That means my displacement is in this direction. My displacement is in what direction? In this direction. When you apply a force, the body is being displaced in the direction of what? Of that force. That is when work is done. Work is only done. Positive work is done when force applied causes a body to move or to be displaced in the direction of what? Of that force, right? But there is a negative work done by friction. If this object is going this way, the applied force is in the same direction of displacement. So the applied force is doing a positive work because the applied force and displacement are acting in the same direction. This is what defines work, right? But look at this, frictional force acting against is acting in the opposite direction. If the body is displaced this way, friction is acting this way. So since friction is acting opposite to displacement, I mean friction is doing a negative work, because positive work is only done when the force applied on the body causes the body to move in the same direction or displacement of what of that body. So here we are saying that when force applied, sorry, when force applied is in the direction, when force applied rather is in the direction of the displacement, the angle formed between force applied and displacement is what is 0 degree. When the force applied, when force applied and displacement are in the same direction, horizontally, the angle formed is what is 0 degree. So from here, my work done is the what force applied times displacement cos what? Cos 0. And cos 0 is what? Is 1. So if I have cos 1, cos 0 as 1, that means my work done by applied force is simply what? Force times what? Displacement. Force times displacement. Okay? Force times displacement. But Fr and displacement are acting in different direction. So the angle formed there is what? Is 180 degree. Okay, they are collinear, they are on the same plane, right? So if Fr, since Fr and R are acting in different direction, the angle formed is what? Is 180. When you find cos 180, the answer is -1. So -1 times Fr, that will give us what? Minus Fr. So from here, I can say that our work done is equals to minus what? Fr. Here, our work done is equals to what? Fa times what? R. So you can see that when the force is in the same direction of displacement, the angle formed is 0. That means the force there is doing a positive work on the body. But when this and this are acting in different direction, the angle is 180. That means that the frictional force is doing a negative work. That means frictional force is taken from the body, is taking an energy from the body. Okay? And if an energy is being taken from the body, as the body is moving, the body have to come to rest. That is why we are saying that work done by friction must be negative, because energy is being lost in the process. All right. Now there's something we call work energy theorem. Work energy theorem. I want to talk about work energy theorem. Work energy theorem says that the total work done by all forces acting on this body, apart from Fa and Fr, there are other forces that act. The other force is what? The mass of the body. When you keep a body on a surface, the weight is acting downward. There's a force here acting upward called the normal reaction, which is what? Mg. These two forces, they are equal but opposites. So the sum of all forces along the y-axis is 0, because the body is moving horizontally. So the sum of their force is 0. I can only find my resultant force along what? The x-axis. But that is not my concern, because I'll talk about all of this during friction. Go back to my class on friction and all that. So please take note that work energy theorem states that the sum of all forces, okay, the sum of all forces, or the work done rather, the work done by all forces acting on the body is equal to the change in its kinetic energy. The work done by all forces is equal to what? Change in what? Somebody's kinetic energy of the body. Don't forget that before the body moves, the body is at the initial position. When a force is applied, the force causes the body to leave the initial position to a final position. So there must be a change in kinetic energy done by what? All these forces. That means that the sum of the entire force in this system is equal to the change, because the body must have to move away. In as much as Fa is applied and the body moves, all these forces are also part of the whole process. That means that if I'm talking about work energy theorem, I'm including all the forces acting on the body. So the sum of the work done by all these forces that act on the body is equal to the change in its kinetic energy. So take note that when you hear the word work energy theorem, the theorem says that the work done by all forces acting on a body is equal to the change in its kinetic energy. And that means my work net is simply kinetic energy, final kinetic energy minus initial what? Kinetic what? Energy. So that means that, but you have to take note that since the body is at rest, the body is at the origin, my initial is actually 0. From here, I can say that my work net is equals to what? Kinetic energy final. Let me bring out the value. I have half, Ke is half what? Mv squared. So if I'm to say final, that means I'm going to use mv squared. My v is final velocity minus half what? M what? U squared, right? But u is equals to 0 meter per second because we are looking at the body. The body was initially at rest before the force is applied. So the total work net is simply equals to what? Somebody half what? Mv what? Mv squared. So this is the expression using relating work net, total work done by all forces. But I want us to look at the equation that was given. The equation was given. Okay, what theorem? Someone say I should repeat the theorem. What theorem is that? Okay, work energy theorem says that the sum of all forces acting on a body is equal to the change in its kinetic energy. The sum of all forces acting on a body is equal to the change in its kinetic what? Energy. Please take note of that. This is the marking scheme we should indicate. The equation says that a body is dropped from rest. A body is dropped from rest. A body is dropped from rest at a height above the Earth's surface. Using the work energy theorem, what will be its kinetic energy before it strikes the ground? Before it strikes what? The ground. Let's look at this question. Sorry, let me check my. I hope you guys are following. Wow. Oh, wow. I hope you guys are following. Just a little bit. Give me some time. All right, so let's continue and see how far we can go. Let's continue and see how far we can go. Okay. Question says that a body is dropped from rest. A body is dropped from rest, meaning our U is 0. It's dropped from rest, right? U is 0. This is not clear, but let me try and get it. It's dropped from rest at a height above the Earth's surface. At a height above the Earth. Let's say we have a height here, and the body is dropped from this point here. The body is dropped from this point here. Our U is 0 meter per second. It's dropped. So let's say we have here, this is our height. This is the ball. The ball has a mass. It has a force, weight, all right? This is the real weight of the ball. Okay, the mass of the ball. So the height is here. Let's go. So we are not told that if it's dropped from above the Earth's surface, okay, using the work energy theorem, what will be its kinetic energy before it strikes the ground? Wow, look at it here. In this case here, if you have to find what will be its Ke before it what? before it strikes the ground. What you need to do is that you have to state that the total the net work done by all forces equals to what? Change in what? Kinetic energy. Then work net equals to what? Ke final minus Ke initial, which is half mv square minus half mu square. We are told that u is 0, which is this. I always say, before the body lands, the speed there is 0. I hope you are following. Hope you guys are following. Sorry. I hope you are following. I hope you are following. I hope you are following. I hope you are active. Hope you are active. I don't know if this is, if you are listening, if you are hearing me. Okay, sorry. Now what will be is Ke before it strikes the ground. But we are told that u is 0. What you need to do is this. Draw this diagram first. When you are done with this diagram, then proceed to this. Proceed to what? To this. Then when you are done, what will be is Ke before it strikes the ground? Abi? Before it strikes the ground, listen. Before it strikes the ground, okay? Before it strikes the ground, there is a speed at which the body is moving. The speed is not initial speed because we are told that u is 0. So that means the only speed the body is moving with is what? Is v, which is what? A meter per second. So from equation of motion, that says that v squared equals to what? U squared plus what? 2ax, right? In this case here, since I'm dealing with height, here becomes what? V squared equals to what? U squared plus what? 2gh. Abi? 2gh. Are you there? Since we are told that our initial speed is 0, so since u equals to 0 meter per second, that means my v square equals to what? 0 square is 0. We are left with what here? 2gh. But don't forget that we have always said that our work energy theorem is what? Half what? Mv square, right? Our work energy theorem is half mv square. Don't forget what I said. After this diagram, you put down this, then you start with this. Okay. Work energy theorem. Recall that change in kinetic energy, right? Sorry. Work net is equals to what? Half what? Mv squared. So our work net is simply half m in bracket, half m in bracket. Our v square from here, our v square is what? 2gh. Can I replace my v square with 2gh here? That will give us 2gh. 2 can cancel 2 from here. So the work net is simply what? Mg what? H. Final what? Answer. This is the final answer for this question. This is the final answer. Using work energy theorem, what will be its kinetic energy before it strikes the ground? Our Ke before it strikes the ground is mgh. Okay? Even before it strikes the ground, the Ke at the top is still mgh. Ke at the middle is mgh. Ke at the ground is what? Mg. Why? Because mechanical energy is conserved at the top, at the intermediate, and at the ground level. All right. So since your question is not involving mechanical energy conservation, I would have loved to show us it, but there's no time. Let's just go straight to the point. But our final answer is what? Is mgh. The Ke before it strikes the ground is same as the work net, which is what? Mgh. So I can say that therefore, that Ke before it strikes the ground is what? Is mg what? Okay, let's move on. Please, if you are active, please indicate that you are active. If you're active, indicate that you're active. If you're active, please indicate that you're active. Indicate, 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 indicate. Okay, Thank you so much, Adeze. That means you are following. Indicate, 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 indicate. Okay. Now the next question here is under friction. We know what is friction, right? Friction is a type of force, is a type of contact force that acts between two surfaces in contact, right? It's a force of opposition. Friction is a force of opposition. Sorry. Friction is a force of opposition. Friction is a force of what? Opposition. Is a force that opposes the relative motion between two objects in contact. Okay? And friction is a type of force called what? Contact force. There are two types of friction. We have what we call static friction. Static friction, also known as what? Limiting friction. Number two, we have kinetic friction, also known as what? Dynamic friction. Dynamic friction. Okay. Static friction, I'm going to define, is the maximum force that must be overcome so that a body can just start to move over another body. Static friction is a friction that must be overcome so that a body can just start to move over another body. Or in a short form, this is a frictional force that acts on the body at rest. That acts on the body at rest. But I would have preferred to use the first one, if you can remember that it is the maximum force that must be overcome so that a body can just start to move over another body. Frictional force is equals to mu r, right? Okay, for horizontal body, a body kept along the horizontal axis on a friction on a rough surface rather. So if I should apply a force, there is always what? A resistive force, Abi. So the connection between frictional force and normal reaction. Normal reaction is the upward force called what? R, right? Normal reaction is always acting upward. The weight is always what? Acting downward, right? Normal reaction is the force the body is exerting on the surface rather is exerting on the body. I repeat again, normal reaction is the force the surface is exerting on the body, while the weight of the body is the force the body is exerting on the surface. Okay, so the connection between frictional force and normal reaction is that frictional force is directly proportional to normal reaction. So that means that as normal reaction is increasing, friction must also what? Increase. So if they are directly proportional, that means they are positive to each other. They are positive to each other. All right? So if the frictional force here is static, that means here will be what? Fx equals to what? Mu x. Now, where mu represents coefficient of friction. So for that of mu x means what? Coefficient of static what? Friction. I did a video on friction. Please, I want to beg everyone of you, there's still time. You can go through that video. It's a live class we did on friction. Everything, friction in details. We solve all the exercises in your textbook. Under friction. About 8 to 9 questions we have solved, and they are all in my YouTube channel. So after the class, just go back and look at them and master them. In case they want to, pick any question from there, you can always solve another. So static friction is equals to what? Mu SR. But for this to be equal to mu SR, we say this what? Here the word maximum static what? Friction. I will explain this when we proceed, all right? Then the other one is called kinetic what? Friction. This is the frictional force that must be overcome so that a body can move over what? Another body with a constant what? Speed. Okay? Kinetic friction is a frictional force that must be overcome so that a body can move with a constant velocity over another body. Or, on a nutshell, this frictional force is a frictional force that acts on the body in motion. When the body is already in motion, that means that the body possesses what kinetic or frictional force, a force of opposition that always acts on the body to cause the body to stop, right? That's what kinetic or frictional force. But look at this here. Like I said, if I have a body here on a rough surface, and this body is held by a frictional force called what static, right? Then I have my applied force here, meaning I want to move this body from my normal reaction from this point away. What do we do? The applied force must be greater than the static frictional force, must be greater than this frictional force. If not, the body will not move. Let's say, for example, if my Fs is 2000 and my applied force is 1050, the body will not move because the frictional force is greater than the applied force. For the body to move, if my Fa is 2000 Newton and the static frictional force is also 2000 Newton, what do you notice? The body will just begin to move. The point at the moment where Fa and Fs are both equal, we have what we call maximum static frictional force. Maximum static frictional force, which is equals to what? Mu x what? R. Mu x r. We call this what? Limiting. This is when the word limiting frictional force comes in. Limiting frictional force is occur when Fx maximum is equals to what? Mu x what? R. Or I can say that it occur when the applied force is equals to what? The static what? Frictional force. So that's why most of the time we use the word limiting for static. But in a nutshell, limiting can only come in when Fa equals what? Fx. At that moment, the body just begin to move. If you apply an equal force here, the body will check. The body will not move. There will be an adjustment, right? But when Fa now exceeds Fx, let's say instead of having 2000, and I have 2500 Newton. At this point where Fa has exceeded Fx, the body will start accelerating, will start accelerating. Exactly like somebody. As the body starts moving or accelerating, this frictional force here will now be what? Fk. Do you get? So our Fs will be converted to Fk because the Fa has exceeded what? The Fx. So the body will now move with a frictional force called what? Kinetic what? Frictional force. But for the body to come to rest, as the applied force exceeds the frictional force, the body is moving. For the body to stop, actually, there must be a point where by the applied force is now equals to what? Fk. Don't forget that at this point here, Fa is greater than Fk. The body is accelerating. A point will come while the body is moving, whereby Fa and Fk are both equal. The body will now move with a constant what? Velocity. That body will now move with a force called the drag force. The what? Drag force. The drag force. As if we are dragging the body. So as the body moving with the drag force, the body will have to come to rest. Because why? The two forces are balanced for each other. Alright? Okay. And for the body to come to rest at an instant, I can remove my applied force. When the body is moving with if my Fa, let me say something here. If Fa equals to Fk, the body moves with a constant what? Velocity, right? At that moment, the body is not accelerating. Acceleration becomes what? Somebody 0 meter per what? Second square. The body is not accelerating when applied force equals to what? Fk. The body only moves with a constant velocity. Then when the applied force is removed entirely, let me say I now remove the applied force, but the body is still moving. The body must have to come to rest. I mean, at that moment, the only force acting on the body when the applied force has been removed is Fk. And that force is equals to sum of Fs equals to minus what? Minus Fk. Minus Fk because Fk is now doing a negative work, trying to stop the body from moving. Now let me analyze one or two things. I hope you guys are following. I hope you 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 are following.
I hope you are active. Can you guys still hear me? My mic is no longer working again. My mic is no longer working again. The next one says that I've already defined static and kinetic friction, right? The next one says that what are the advantages and what disadvantages of what friction? This is very simple. What are the advantages and what disadvantages of friction? What are the advantages and disadvantages of friction? Who can tell us the advantage? In the comment section, anyone? Advantage is that friction makes working possible, right? It makes working possible. That's question number one. Excuse me. Let me get the question again. Please, if you are active, indicate that you are active. We have really learned so much. Please ensure that you go through all the lecture notes. Thank you. Advantage. Someone say it prevents sliding. Friction prevents what? Sliding. Friction prevents sliding. It makes walking possible, right? It makes walking possible. All right. Friction is also used in grindstone to sharpen knives and chisel. Friction is used in grindstone. In grind what? Stones to sharpen what? Knives and what? And chisel. It is used in grindstone to sharpen knives and what? And chisels. Friction is also used, okay? It is used to, it is also applied. It enables a brake to be applied, right? On a car. Friction enables a brake to be applied on a car. It makes writing possible. For you to write with your pen, it means it is the job of what? Of friction. It is the job of friction. Alright? Then disadvantage of friction. One, it causes wear and tears. Disadvantages, it causes what? Wears. And what? And tears. Number two is that friction causes overheating. Overheating. Over what? Overheating. Number three, friction reduces speed. It reduces speed. Reduces what? It slows down speed. It reduces what? Speed. Friction also causes energy loss. Loss of energy. What are the methods of reducing friction? Number one, lubrication. One is what? Lubrication. Number two, streamlining. Number three, ball bearing. Ball bearing. One is lubrication. Method of reducing friction, lubrication, use of lubricant, streamlining, ball bearing. We have polishing. Polishing. Number five, we have banking of rolls. Banking of rolls. etc. Banking of rolls. etc. Okay, these are the methods of reducing what? Friction. Method of reducing friction. I hope you guys are still active. I hope you are still active. I hope you are very much active. Yeah, banking of rolls, polishing, ball bearing, streamlining, lubrication, and so on and so forth. A lot of them. A lot. I'm going to stop here now because I need to prepare for Night of Revelation. If you are free, you can join us tonight. A lot of things will be discussed. Possibly you might not see this. You might see something else in the exam. So we are exhausting every options. So ensure that you join us tonight by 8 p.m. Our class starts by 8 p.m. and we're not streaming it online. You can see the challenges we are having. My phone is almost going down. It's about 2%. So very soon the live will be cut off. All right. So please ensure that you join us by 8 p.m. Invite your friends. Come on time. As early as 8 p.m. I've started my class. So if you come late, you might not be able to meet up. So see you guys in class. Thank you so much. See you guys in class. See you guys in class. And ensure that you save this video and share to your friends. Share to your friends, your classmates. Let them subscribe. Share this video to them. All right. Thank you. Thank you. See you in class. 9th of Revelation is by 8 p.m. It's by 8 p.m. For those of you who are shouting. We had the first class yesterday. It was so powerful. We learned biology and we have reviewed biology. Everything we learned in biology will surely appear in the exam. So we had little time for physics yesterday night. But this night will be physics from 8 p.m. to 4 a.m. You can imagine the intensive class. And please, if you are interested, you can join us. Just 1,000 naira to join. 1,000 to join. We're not charging much. And the environment is secure. We have our security intact. We have everything. And we have EMI-BRAIN teaching tonight. Okay? Imagine if you are in a physical class with me, with what you are learning now. The impact is something else. So please ensure that you join us this night. Come along with your course mates, with your course reps, and everyone you can invite them. Thank you. Students.